Hey guys, what's up? This is Mr. Myasis here, and I'm repping my purple and gold with my Lakers in the background here. They're better. My teams are doing okay this year, um, but hey, it's not what I'm here to talk about, right? I'm here to talk about partial fractions. So another technique in Calculus BC or Calc 2, where we are looking at separate. So when we had two fractions, we're separating fractions. What we're doing. So basically, let me step back here. We had two fractions with different denominators. We would put them together as one fraction by finding a common denominator. Well, we could do the reverse process and split them apart, and that's called the process of partial fractions. So here's a couple of things that you need to know before deciding whether or not to use partial fractions. First, you should look at, I'm sorry, my phone's blowing up here. You should look to see if the denominator can be taken, if you could take the derivative of the denominator and see if that is in fact the numerator. Because if it is, then you're just doing a reverse chain rule for a natural log. If the denominator's degree is higher than the numerator's degree, so like an x on the top and an x squared on the bottom, then it's likely you're going to do partial fractions. And we already talked about if the denominator is higher than the numerator, we're going to use long division, right? So let's take a look at using partial fractions. Basically, again, what we're doing is we're splitting apart the denominator. We're splitting apart the fraction into two separate fractions. And one of the things that you're going to look at too, what you're going to do is you're going to look at non-repeated linear factors on the denominator. So for BC Calc, that's really all you're going to need to worry about. We'll take a look at these. So let's take a look at the first example here. If my computer will move, for some reason it is not. All right, sorry guys, it's slow. All right, so here we have example number 1. And what I'm going to do is for partial fractions, I'm always going to factor the denominator, okay? So I'm going to factor the denominator, and the denominator is going to factor to x minus 3 and x minus 4. And what I'm going to do is I'm going to put them in two separate fractions. And they're going to be some a and b that makes this happen, right? Some a and b are going to be on top so that when I separate those factors into two, I'm going to get something like this, which is what I had to start with, right? So if I add whatever those a and b are going to be, they're going to be something. Our goal here is we're going to find a and b. And now, in order to find that, if you remember, we're going to get this, what we're going to do here is we're going to get rid of the fractions to solve this out. So in order to do that, what I'm going to do is I'm going to multiply this one by x minus 3 times x minus 4, this one by x minus 3 times x minus 4, and this one by x minus 3 times x minus 4. Basically, I'm going to multiply everything by the common denominator. That's clearing the fraction. These cancel out. I'm going to have a times x minus 4 plus b times x minus 3. It's almost like you're cross-multiplying here, equals 1. Okay, so now what am I going to do to find a and b? I've got a, b, and I've got an x. So what we're going to do is we're going to do a little trick here where we're going to say, let's set x equal to 4. All right, let's just suppose x was 4. Because if it was, then I would have a times 4 minus 4 plus b times 4 minus 3 equals 1. I would have a times 0, which is just 0. And I would have b equal to 1. Let's do that. And let's let x equal to 3. That would give me 3 minus 4 plus b times 3 minus 3 equals 1. That would give me a equal to 1. Or actually, that would give me negative a equals to 1, which gives me a equals negative 1. Look at that. I found a and b. Some of you are probably thinking to yourself, wait, Mr. Myasis, can I really do that? Can I just set x equal to 4? Doesn't that seem like cheating? Well, no, that's called math. That's algebra, all right? Because this happens for any x value. So we're going to just set the x value, the one that we want to be the easiest, which is to cancel one of these out. So when you're doing partial fractions, look to cancel out one of those x's by making it a 0. All right, so we're going to go back and fill this guy in. So we're going to have a is negative 1 over x minus 3. B is positive 1 over x minus 4. And we're going to integrate that now, dx. Okay? So let's go and integrate that. Negative 1 over x minus 3, that's a logarithm. So we're going to have negative ln of x, absolute value of x minus 3, plus natural log of absolute value of x minus 4, plus c. And we got our answer. All right? So that is the method of integrating by partial fractions. I don't know if my... Okay, anyway, let's go on. Let's look at the second example here. So again, we need to, if we did the derivative, we get 2x minus 2, which is not what the top is. So that's not, we can't use the reverse chain rule. So I'm going to do a over, factor that out. This factors to x minus 3 times x plus 1, plus b over x plus 1 equals 5x minus 3 over x plus 1 times x minus 3. Then I'm going to multiply, right? And we're going to end up with a times x plus 1 plus b times x minus 3 equals 5x minus 3. Okay, so again, I'm going to say let x equal negative 1. Okay, if x equals negative 1, then the a is gone, right? And I'm going to end up with b times negative 1 is going to be negative 4b equals negative 8, which is going to be b equals to 2. And then I'm going to let x be equal to positive 3 so that the x part right here on the b gets rid of the b. And then I'm going to have 4b equals 3 times 5 is 15 minus 3 is 12. Actually, this is a. Sorry about that, guys. 4a. And a is going to be equal to 3. Perfect. So now I'm going to get the integral of 3 over x minus 3 plus 2 over x plus 1 dx. Okay, because I substitute a and b up here. Okay. All right, so what's that going to be equal to? Well, this is 3 ln of absolute value of x plus x minus 3 plus 2 ln absolute value of x plus 1 plus c. All right, and there is our answer. All right, integration by partial fractions. Okay, so now on this one here, we're going to go and check to see if this derivative works. Here we're going to get 2x minus 2. Whoa, wait a minute, that's the derivative. So this is actually a hook. All right, so really I'm looking at the integral of 2x minus 2 times x squared minus 2x minus 2 to the negative 1. Actually, it's down here on the bottom. Sorry, I can't put it up to the negative 1. Okay. Psych. All right, so really just I'm looking at the natural log of x squared minus 2x minus 3 plus c. That's it, okay? So don't be fooled. Don't think, oh, I got to do partial fractions, because you might not have to. You got to check that out, all right? All right, so the top here is bigger than the bottom. So I'm not going to use partial fractions yet. I'm going to first do my long division. So I'm going to do long division on the side here. Let me use black here. X squared plus x minus 2, x cubed minus x. Oops. Sorry, guys. Forgot I need a placeholder. Minus x plus 2. Okay. So I'm going to need an x here. This is going to give me x cubed. Okay, I'm going to pause it here. I'm going to finish this out and then come back. All right, so coming back, I did finish my my long division here, and I just substituted in all the whatever I did for my long division up here into my integral. Okay, so I have the integral of x. Oh, someone's at my door. I got a ring. Integral of x here is x squared over 2 minus the integral of 1 is just x plus the integral of 2x over x squared plus x minus 2. Now, if I took the derivative of x squared plus x minus 2, I get 2x plus 1, which is not going to work. So I'm going to need to use partial fractions. Okay, so I'm gonna work on partial fractions on this part right here. So I'm gonna have this is gonna be a. If I factor this out, this is gonna be x minus x plus 2, x minus 1. So I'm going to have a over x plus 2 plus b over x minus 1. And this is, now you know what? You know what I'm going to do? Okay, guys. I'm going to do this work on the side here. Okay. So I'm going to have a over x plus 2 plus b over x minus 1 equals 2x over x plus 2 x minus 1. Okay, so then I'm going to end up with a times x minus 1 plus b times x plus 2 equals 2x. And I have to figure this out now. So what am I going to let x equal to? Okay, I'm going to say let x equal 1. So the 1's going to get rid of this a part, and it's going to leave me with 3b equals 2. So b is 2/3. And I'm going to say let x equal negative 2, which is going to give me negative 3b, which is 2 times negative 2 is negative 4, which is going to give me, man, why do I keep doing that? Keep putting that b. It should be a. All right, so then a is going to be 4/3. All right, so now let's go back and finish this guy off here. Let me put this over here where I got some more room to work here. So we've got x squared over 2 minus x plus the integral of 4/3 over x plus 2 plus 2/3 over x minus 1 dx. And remember, I got this from my partial fractions that I did right here, right? Okay, so I figured out the partial fraction, split that apart. Okay, so what does this end up being? Well, we've got x squared over 2 minus x plus 4/3 natural log of absolute value of x plus 2 plus 2/3 natural log of x absolute value of x minus 1 plus c. Man, aren't these just beauties? All right, guys, there you go. That's integration using the technique of partial fractions. We'll see you soon. Bye.